Hello students, right here again. Okay, we continue on 16.1 notes. We'll finish up the section today. Last time we looked at some of the basic properties of electric charge. Today we're going to look at differentiating between conductors and insulators and distinguishing between charging by contact, charging by induction, and charging by polarization. A couple charts first. One just giving basic fundamentals of the electron, proton, and neutron, masses, and charge in coulombs. And then some conventions for representing charges in electric field vectors: positive charge, plus Q, negative charge, field vectors, electric field lines, things we'll be using as we go along. So, if you rub a balloon on your hair, only the rubbed areas become charged, and there's not a tendency for charge to move in other regions of the material. So, no tendency. Other materials, such as copper, aluminum, silver, can be charged in some small region. The charge distributes itself over the entire surface of the material. So some materials, charges don't move. Other materials, they do move. So, and we can classify in their ability to transfer electric charge. So, materials where the electric charge move freely, called conductors. Metals such as copper and aluminum, excellent conductors. So, most metals, conductors. And materials where the charges don't move freely, such as glass, rubber, silk, plastic, call those insulators. A couple other classes we come up with. Semiconductors have properties somewhere between those of insulators and conductors. In pure state at normal temperatures, semiconductors are insulators. And if we add some impurities to them, they can increase their ability to, impurities can increase the ability to conduct electric charge. Silicon, germanium, a couple of the more common semiconductors. And we get a fourth class we call superconductors. We get some metals and compounds. Superconductors have a zero resistance when at or below certain temperatures, so we cool them down. Their resistance gets very, very low. And what makes this useful is they conduct electricity without heating. If you run electricity through copper wire, aluminum wire, they tend to heat up. And if you run too much through it, they heat up very much, and this is what can cause fires in a house. So, and here we move into different ways of charging things. So both insulators and conductors can be charged by contact, such as balloon and hair, rubbing together, charging by contact. Another example, glass rod rubbed with silk, rubber rod rubbed with wool fur, both of those will be charged by contact. So 2 rods, the balloon and the hair, whatever else, they become oppositely charged as this process goes through. What's happening is electrons are being transferred from one substance to the other. Now, if we charge 2 glass rods, they're going to have the same charge and repel each other, like the two balloons. 2 rubber rods will repel each other when we charge them. So all these are insulators. Insulators, very easy to charge by contact. So can conductors be charged by contact as well? So if we did it with a copper rod, the rod doesn't attract and repel another copper rod. That's because these electric charges produced by rubbing readily move from the copper through your body and finally to the earth, because copper and human body are both good conductors. So the charges just flow through. So the copper rod does become charged, but it soon becomes neutral again. So this doesn't stay charged very long. So this might give us the idea that metals can't be charged by contact. But if we adjust it just a little bit, if we hold the copper rod with an insulating handle and then rub it with wool or fur, the rod attracts a charged glass rod and repels a charged rubber rod. The copper rod does become charged, but we have to insulate it from the earth. So we need a insulating handle. So this insulating handle prevents the flow of electrons to the earth. So both insulators and conductors can be charged by contact. Just we have to add this insulator on the conductors. Another method we're going to look at, conductors can be charged by induction. So if we connect a conductor to the earth by means of a wire or a copper pipe, a conductor is said to be grounded. Earth can be considered an instant reservoir for electrons because it can accept an unlimited number of electrons. And this allows us to do this charging by induction. We charge by induction. We bring a negatively charged, here rubber rod, could be any negatively charged thing, or the opposite would work with positively charged also. So we bring a negatively charged rubber rod near a neutral sphere as illustrated here, and no conducting path to the ground. This causes a redistribution of negative charge on the sphere. As we see here, all the negatives get pushed off away from the negative charge rod. So it causes negative, like charges repel, they work their way opposite. So the region of the sphere near the negative charge rod has an excess positive, away from it has excess negative. Now, if we can connect a conducting wire, a grounding wire. illustrated there. That allows some of those electrons to leave and travel to the Earth. Then we remove the grounding wire while the negatively charged rod is still held in place. So now we remove it, and then we remove the negatively charged rod. The sphere remains with a positive charge. So this process, called induction, charge said to be induced on the sphere. So, charging by induction, no contact, but does require contact with a third object, such as the Earth, which is going to serve as either a source or a sink of electrons, depending on which way we're looking at going here. And a sink, a system which can absorb a large number of charges, such as the Earth, without becoming charged itself. So, process of inducing a charge on the sphere. The charged rubber rod did not come in contact with the sphere, so no contact there, and did not lose any of its negative charge. So, contrast charging by contact, charges are directly transferred from one object to another. So here's our definition for induction. Make sure you have that one written down, no matter what else you've written down. And one more process we're going to get to. It's very similar to induction, slightly different. So, in the presence of a charged object, the charges in a neutral object may shift slightly, resulting in more positive charge on one side than object on the other. We call this polarization. So, polarization here. It's a pretty good definition there for it. So, we get what we call a surface charge by polarization. Polarization charges in an individual molecule are slightly realigned, so the molecule has a slight charge separation. So kind of like in the induction where we brought the charged object next to it, it causes things to shift. Same thing happens here, except it's not a permanent shift. So, realignment of charges. So we get this realignment of charges illustrated here in this picture. So one side of this insulator becomes negative, one side becomes positive, depending on whether we brought a positive or negative charged object next to it. So the object being polarized still has no net charge, but is still able to attract and repel objects due to it. Such as if you charge a comb, run the comb through your hair a few times, it may become charged, and then it can pick up pieces of paper, even though the papers have no charge. It polarizes the piece of papers and allows charges. And see in the picture here, paper connects to paper connects to paper. You get this polarization process happens all through this string. So we have induces a charge with no physical contact. But if we take the comb and uncharge it, then all the paper is just going to fall off because the paper does not have a charge. So that's a little bit more out of section 16.1 here. Yeah. Make sure you have some good notes from it. You can read through the textbook also, take notes. Next thing we'll have, we'll go through some questions on section 16.1. So until next time, Mrs. Strike.